This example is a polynomial function of higher order. The function looks like this: f of x equals negative 5x squared minus x cubed. I'm going to change it to f of x equals negative x cubed minus 5x squared. I'm putting that in standard form, which is in descending order. Notice the degree here. The degree is 3. That tells us the shape of the graph is a snake. So our degree is 3, which is odd. And then our leading coefficient is a negative. It's less than 0. So that tells us we're going to fall on the right and rise on the left. So it's going to look something like this. We're rising on this the left-hand side, and then it's going to fall on the left. Sorry. Here's our left, here's our right. It's going to look something like that. So now we want to find the zeros of the function so we can find those x-intercepts. So I'm just going to use that green function in standard form. I'm going to set the function equal to 0 and solve for x. I'm going to try and factor it first. That's the first way to see if you have some zeros of the function. So I'm going to take out a GCF of negative x squared. I'm left with x plus 5. Then I set those zeros, which are these two, equal to 0 and solve for x. So I get negative x squared equals 0 and x plus 5 equals 0. If I solve this for x, I divide by 0 or divide by negative 1, I still get 0. This is telling me I have a repeated 0 at 0, and its multiplicity is 2, which is even. So that tells us when we graph that x-intercept at 0, 0, it cannot go through the x-axis. It's just going to touch the x-axis. So that's a little bit about the repeated 0. The other x-intercept, or 0, is at negative 5. And then at 0. So step 3 is to identify the x-intercepts. I have an x-intercept at 0, 0, which is a repeated 0, multiplicity of 2. So it's just going to touch the x-axis. It will not go through. And I have an x-intercept at negative 5, 0. Step 4 is to graph those x-intercepts and then the end behavior. So here's my x-axis. I have an x-intercept of 0, 0. Then I have another x-intercept of negative 2, negative 4, negative 6. I'll have an x-intercept at negative 5. My end behavior. My end behavior on the right side has to fall. So if I go to the farthest right x-intercept, which is right here, it has to fall. It has to decrease. Then on my left-hand side, my end behavior is rising. So I go to the farthest left x-intercept, which is this one, and I rise. Now, if you remember the multiplicity, this x-intercept is going to come up, and then it must go right back down. It can't go through the x-axis. So it's going to come up and then go right back down. What I want to do is find out what's happening between here. So I'm going to evaluate the function, and that's what this step 5 is. Plot a few additional points around the x-axis. So you may want to try something like negative 4 or negative 2 and find out what happens. So we evaluate the function. So you can either plug it into the original blue one or the green one. So here's our function, f of x equals negative x cubed minus 5x squared. To find our first point, let's just let x equal negative 2. So I evaluate the function at negative 2. Replace the x with negative 2. Replace the x with negative 2. We do our orders of operations first. Negative 2 times negative 2 times negative 2 is negative 8. Negative 2 times negative 2 is positive 4. Then negative 8 is a positive, and then negative 5 times 4 is 20. And we get negative 12. So the ordered pair here is at negative 2, negative 12. So I'll erase this here. At negative 2, we're down here at negative 12. So coming down. And then eventually we must come back up to meet that x-intercept. So I'm just going to let x equal negative 4 and see what I get there when I evaluate the function. So let x equal negative 4 in the function. So f of negative 4 equals negative, replace the x with the negative 4, replace the x with the negative 4. Negative 4 times negative 4 times negative 4 is negative 64. Negative 4 times negative 4 is positive 16. Negative negative turns out to a positive 64. Negative 5 times 16 is negative 80. And we get negative 16. So we're still down here. At negative 16. Eventually we're going to come back up at negative 5. So here's the shape of our graph.